So good evening, everyone. So welcome to this live session on activity questions in Python. So just give me 2 minutes, we'll get started. So I hope the screen is visible to all of you.
Yes, sir.
Okay. Let's wait for one more minute in case someone else wants to join. Okay, so someone has asked, how can we use Spider in Windows 7? Okay, so I am probably not the right person to answer this. I don't have Windows, nor do I use Spider, but you can search online that, or if anyone else is using Windows 7 and Spider, can someone answer that in this group? Is anyone using Spider on Windows 7?
Sir, I think it is the same process as on Windows 10, like downloading it from Anaconda.
Okay. All right, I think we have we can start now without further delay. Okay, so the plan is we'll go question by question, and if you have any doubts in that particular question, please stop me and we'll discuss the answer, right? So the question here is to accept a positive integer and print the number of factors of x, right? So let's just take that first line and let's quickly code it up. Okay, so just to see if my replit is working fine. All right, so you have to accept some positive integer, some number x, which is an integer, and we'll have to find the number of factors of x, right? So what we'll do is for I in range of 1 comma x plus 1, because the factors can be 1 and x are anyway factors, so we'll have to check for all the values. So if x is divisible by I, okay, so I write that as x modulo I is equal to 0, that is the remainder when x is divided by I is 0, then I'm going to, let's say, print that particular factor. So let's just try this out for the number, say 10. Okay, so we get 1, 2, 5 and 10 as the factors. So there are 4 factors, but the question actually asks us to count the number of factors. So what we'll do is, instead of printing it, we are going to count it, right? And if we plug in 10 again, we'll get 4. Okay, so that's the basic solution to this problem. So that's not the end of the question. So I got zoomed out, I don't know why. Yeah, so we are also asked to divide the test cases into 2 classes, squares and non-squares. So did any one of you observe any pattern? The answer is there, but I'm still asking, were you able to figure out that pattern? Anyone?
Hello, sir.
Yeah.
For non-square, there is even number of integers, and for
Okay.
square there is odd number of integers.
Okay. All right. Yeah. So that's the basic observation. It's more of a mathematics problem, that particular part, than a programming problem, right? So yeah. So unless there are any other doubts, I think we'll move on to problem 2. Okay. So we are asked to consider the following sequence and find the first element in the sequence that is divisible by 2003. And for that particular element, how many digits are present in it? Okay, so what we'll do is we'll first go ahead and build the sequence. I'll start with the first number in the sequence. So clearly, I don't know when the sequence is going to end, right? So I just say that as long as this it's true, we are going to keep going on and on, right? And if my sequence is divisible by 2003, right, I'm going to break. All right. If not, what I'll do is I'll go to the next term in the sequence, which is nothing but sequence times 10 plus 7. So for example, if you have 7, then the next is 77, which is nothing but 7 into 10 plus 7, right? And 777 is nothing but 77 into 10 plus 7. So that's the idea. So let's see what we have here. Okay, so that is the term in the sequence for which 2003 divides it, right? So how do we find the length or the number of digits here? So one thing that we can do is we can convert this into a string, okay, and then find the length of that particular string, right? So this the 1001st element in the sequence, which is essentially 1001 sevens. So that is the length of the number, right? So I have some questions in the chat. How can I use for loop in the same question? Okay, see, for loop is not a good choice here because we don't know when the sequence will terminate or when the iteration will terminate. However, you can use for loop. There are ways to, use a for loop when you don't know when to terminate it, right? So for loop is probably not the right option. So I have another question. What does while true stand for? Okay, so while true is nothing but uh, it's see while followed by some condition, right? So here you usually add some condition. When you say the condition is true, then you will essentially have an infinite loop. So to demonstrate that, see while true, print 1. So if I run this, what will essentially happen is it will be an infinite loop. Okay, so that is the effect that while true produces, simply because there is this condition never becomes false. All right. So that was one question. I think that is clear now. Another question is, there is again 777 after 777. Is it maybe? Yeah, I'm sorry. So this is an error. So this should have been 4 sevens. I think I missed that. Yes, that's a typo, right? So the solution will be uploaded soon. Okay, so this is not in the portal, but the solution will be uploaded soon. So are there any other problems with this particular question? I hope not. So we'll move on. The answer is exactly the same. So yeah. So this is about a bot that can basically move in one of the 4 directions. And what you are asked to do is find the distance of this bot from the origin. Okay, so now how do we code this up? Okay, so I'll just say that this is the action that's going to be taken by the bot. Okay, and if you notice in the question, it's given that each move is of magnitude 1 unit and the sequence is always going to begin with start and the sequence will end with stop. Okay, so what I will do is while the action is not stop, I am going to look at what the action is. So if the action is equal to, so what are the actions? Up, down, left, right. So if the action is going to be up, then what I'll do is I'll add to the y coordinate of this particular bot, right? So clearly we need an x and y coordinate for this particular bot. So if the action is up, I'm going to increment y. If the action is down, I'm going to decrement y. And if the action is left, then the x coordinate comes into play. So I'll reduce it by 1. And if the action is right, then x coordinate is incremented by 1. Okay. And what happens now is we have the action in place. So can I stop now? And if I run this, will I get the correct answer? So I have made a mistake here. So can someone point out what the particular mistake is? Yeah, so we need to ask for the input again, right? So we'll ask for the input again, and this will keep going on, right? So finally, what we do is the distance of the bot from the origin is going to be the Euclidean distance, which is nothing but x square plus y square, the square root of the whole thing, right? And we'll print the distance. Okay, so that's basically it. So we always have to start with start, right? So yeah, that will that's why we have this first input of that. That's what it will do. So let's just give this input and see what happens. Yeah. So I get 1.414. This looks like a root 2. So let's see if that is correct. So let's see what the values of x and y are. It's -1, 1, right? So it's in the second quadrant, and clearly the distance is going to be root 2, right? So there are some questions in the chat. Why are we taking input again? So the reason is you are taking input once outside the loop, okay? And after a particular action is done, the bot needs to move, right? So in some direction, we need to know either if the sequence of moves has ended, we need to know that, or if it's going to continue, we need to know what action it is, right? Yeah. So I'll come to this nested depth thing at the end after we discuss the activity questions. Okay. So I'll just verify this for one more input, which is 3, 4, 5, right? So if I move 3 units in the x direction and 4 units in the y direction, my distance should be 5. So let's just verify that. So I'm going to start, and then I'm going to move right by 3 units, and I'm going to move up by 4 units. Okay, and I'm going to stop now. So if you notice, we are getting the right answer, right? So it's at 5 units from the origin. Okay, so that's basically the solution to this problem. If there are any doubts, we can discuss that. If not, we'll move on. All right, so I guess there are no other questions, so I'm going to move on. So accept two positive integers n and p as input with p less than or equal to n, and you're going to form the string by placing all integers side by side, right, from 1 to n. So let's first do that. Let's first take n as input. Okay, so what we have to do is we need a string to store this sequence. Let's call it string. And now for I in range of 1 comma n plus 1, the reason I'm doing n plus 1 is because we need to represent all integers from 1 to n, right? So what I'm going to do is I'm going to append the string version of that particular integer to string. Okay, so let's just try it out. Okay, let's say 5. So it's clear, 1, 2, 3, 4, 5. Now what if we give something like 10? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 0, right? So this part is working fine. Now what is the next part of the question? Find the number that is at the pth position in this sequence. Okay, so that means we need to accept p as input from the user, and rather than printing string, I'm going to write an answer, and you need to tell me if it is right or wrong. So is this correct?
Sir, it should be p plus 1 because n not t 0.
Sir, it should be p minus 1.
Okay, yeah, so it should be p minus 1, right? Because p plus 1 would be, so if I give the first position, then that will correspond to index 0 in the string, right?
Yes, yes, sir.
So it should be a p minus 1. So let's just give 10, and so that in the question we have n equal to 15 and p equal to 10. Sorry, p equal to 11, and that should give us the answer 0. So let's just check that. 15, 10. Oh, okay. Oh, it's 11, right? 15 and 11 should give us 0. 15 and 11 gives us 0. Right? So this is a fairly simple problem. If you have any questions, I will stop. Otherwise, I'll keep moving on.
Sir,
Yeah.
in the question, it is said that p should be less than or equal to n. So while writing the code, do we need to write a line of code for that?
Yeah. So it's not necessary. See, it depends on your actual program. So, for example, if you are developing this for some, say, this won't be. This is not something that you'll be doing for a user, let's say, in a company. But in case you come across the situation, then it depends on your use case, right? So you may want to add this one extra line, and it says that okay, so we could do this. So if p, while p greater than n, you just want the user that p should be less than n, right? And you can accept p again, right? So I mean, it's up to you. It's not necessary per se, but it's a good practice to do this.
Okay, sir.
Right? Yeah. So that is that, and we are moving on to problem 5. Yeah. So problem 5 is interesting.
Sir? So I
Yeah.
have a question, sir.
Yeah.
Instead of writing this for loop, can we just directly convert the integer n into string
Okay.
using
Can you give me a method to do that? If we can do that,
like assigning another variable and equals to str of n? Can it?
okay. Can you tell me the exact code so that I can write it down maybe?
No, I am thinking like I don't know if it will work or not.
Oh, you
So
mean,
So
yeah.
t is equal to str
yes,
and bracket of n.
P equal to, is it?
No, no,
yes,
t. Some
yeah,
other
p. Some other variable
Okay.
other
Say
than
some,
n and p.
okay. Say
Like
m equal to,
str
str of
of
p.
n.
okay.
str.
Yes, sir. So,
Yeah.
Yeah, but this will only do it for n, right? We want, see, we what essentially we want is if the input is 10, we want to generate the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0. Did you get the question? So if you want to, if it's 15, then we need to generate this 1, 2, 13, 14, 15. So for this, we need a loop, right?
Okay.
Right. So did you understand the question? Maybe that was not clear. So see, we are accepting n and p. A string is formed by writing all the integers from 1 to n side by side on the same line. Okay, so if it's Is it clear now? 15 means I'm writing 1, 2, 3, 4 all the way till 15, but without leaving any spaces on the same line. And in that, I want to know at position P, what is the number present in the string?
Okay, I'll just enter the limit, like up to which number we have to enter, and the string will, the program will automatically enter the number side by side. That's it. Okay,
Yeah.
I understand now.
Yeah. So there is a question, why should P be less than N? For larger values of P can be greater than N as place values. Okay, yeah, that's a good question. Yeah, Harish, yeah, you are Harsh, right? Harsh is, yeah, your question is valid actually. Yeah, I missed that. P need not be less than or equal to N. You are correct. So, for example, if we just go back to that code, and I think his point is valid, and we need to. So, for example, if let's say N is huge, let's say 100, then there is no reason why P should be less than N. So I'll just remove this code. That will give us a better idea. So if N is 100, P can be, I think, even 200. It shouldn't matter. Or does it matter? Okay, let's just print the length of string so that will give us an idea of. Okay, so it's 192, right? So anything less than 192, less than or equal to 192 should be fine. Right, so that's a valid point, Harsh. So anything that is less than the length, less than or equal to the length of this final string is safe to go. So that restriction is actually not needed, but it should be. But some restriction is certainly needed. It's not a very tight one, I would say. Okay, so we are moving on. So we have an unbiased dice with 12 faces, and it's rolled. The probability of obtaining a prime number is 5 by 12. This is all known to us. So set up a computational experiment to verify this. Okay. So let's see. Okay, first let's see what the value of 5 by 12 is. What we are expecting is the final probability is this, right? So this is the, if you, I mean, all of you have studied stats 1, but this goes back even before stats 1. So a very simple experiment of rolling a dice with 12 faces. There are 3 primes, right? 5 primes, right? 2, 3, 5, 7, 11. Okay, so it's very simple, but what do we mean by a computational experiment? Okay, so what we mean is we are going to roll the dice a certain number of times and find how often a prime number comes up. So how do we do that? Let's look at this way. So I'm going to define a list called rolls that will keep track of all the times we roll a dice. We are actually discussing problem 5, right? Yeah. So in order to roll a die, I need to take the help of the random library. Okay. So since it's an unbiased die, you can uniformly choose a number from 1 to 12. And that can be done as follows. Okay, so random.randint of 1 comma 12 is going to give me it's going to represent one roll of the dice. So how many times do we want to roll the die? It's up to us. Let's say we roll it for like 10 times. So we need to keep track of the number of rolls. So let's use num for that. While num is less than 10, keep rolling the dice. But the problem is we need to store it somewhere. So we are going to do that by appending that particular value to rolls. Okay, now at this point, let's see what our result is. Okay, my replit is taking a lot of time. I don't know why. Okay, I need to restart it. Just give me a second. Okay, so oh yeah, sorry, it's going into an infinite loop, right? So I am not incrementing count at all. Replit is not wrong. I am wrong. So that is what is happening here. So let's. Okay, so we have rolled it 10 times, and this is what we get. Okay, so that is nice. Now we have come so far. Now the experiment that we are trying out is find the number of primes in it, right? So for this, what I'll do is I will just separate it. I'll make this a roll of a die, and I'm going to append this to rolls. And here I'm going to ask if this roll is a prime number. How do I do that? So this is the statement for that, right? Is this particular roll present in the list of primes? Okay, if it is present, then I'm going to increment a count variable. So num equal to 0, count equal to 0 to begin with. Okay, so finally what I do, I after I do the experiment, I come back and print the number of times I observed a prime number. Okay, it says 0.5, which means out of 10 rolls, 5 of the rolls were prime numbers, right? But what we need to get is 5 by 12. Okay, so you can clearly see that this difference is quite large, right? So what should we do to get closer to this particular value? This is the actual estimate, rather this is the actual probability, whereas 0.5 is our estimate. So if I change something here, I'll get closer to this
So
particular.
should we change the number of cases? Like while num greater than 10, we can use while num means less than 20
Okay,
instead of
so
10, 20, 30.
exactly. So let's try. In fact, let's try. Let's say 50. Okay, and print count by num. I'll also print 5 by 12 just to compare the two. Okay, so not bad. Earlier it was 0.5. Now it has become 0.48. We are getting closer. So let's try 100. Okay, now we are fairly close. How about 1000? Okay. We have suddenly shot up. So,
Sir, can I please ask something?
yes.
Sir, why don't we use for loop instead of while loop, sir?
We can. I mean, there's no harm. It's this particular problem we can use both.
Okay, sir.
Yeah.
No, sir. Even in the lectures, no, there are a lot of problems which this professor teach. It will get easier if he uses for loop, but it kind of gets complicated when he uses while loop.
Right. See, here we can use a for loop. There's no harm, but yeah, it's some. See, at some level, it's a personal choice, right? In certain cases, it's
Of
for loop
course,
is
sir.
natural. So
Yes, of course, it is a
yeah.
person.
Right. So what we will do is we are getting very close. I would like to be still more close to this value. Okay. So that's better, but we have done 1 lakh, or so we'll try 1 million, but I think 1 million is going to take time. Okay, I think 3 decimal places is all that we can expect with 1 million, I believe. Right. So yeah. So there we have, right? So this is how we simulate an experiment, and verify that the actual probability 5 by 12 is indeed the correct one, right? I mean, at least we can see that we have approximated the whole thing. All right, so I'll move on unless anyone has any questions here. Was anything not clear?
One thing, sir, here.
Yeah.
We can run same input for the many times. Also, we can see that it is how much vary it's coming.
Yeah. So
Again and again, because it is random number, so every time it will come for the same input, different value. Like right now, it is the 41682 is there. No, again I will run for the same input. Not necessarily it will come only that much.
Yeah, you're right. Yeah. So your question is.
So the thing is that if we will run on the same input, so even after 1,000, it is here the 1 million. After thousands, we will run the same input twice, 3 times. No, it will come sometime up and down, closely related. It will come.
Yeah, exactly. Yeah.
It will never exact reach on the accuracy.
Yeah. So that's a good point. So I'll at this stage I'll introduce this particular function. So what we'll do is we will print the rows here. Okay. Not outside the loop. I'll delete the. Okay. So as you said, if I run it again, it will be a totally different set of values. Now, sometimes what we'll do is for reproducibility, what people tend to do, scientists tend to do is they have what is called a random seed, right? So if I set the random seed, then my numbers will still be random, but every time I run it, I will get the same sequence of random numbers, right? So you get the idea, right? So these are still random. So if I change the seed to something else, then I'll get a different sequence of random numbers. But every time I run this program, that sequence will not change. So this is done for reproducibility purpose, right? So if you're writing a paper, or if you're communicating your idea to, say, someone, and you want them to be able to reproduce the experiment, then you set what is called a random seed. But if we remove this, then we are going to get totally different random number sequences every time.
And what's the effect happen on the getting probability?
The random seed effect on probability.
Yes. Yeah. Can you put that, sir, here also count the probability and use the random seed? I want to see.
Yeah, sure. So let's okay, that's a random seed, and let's run it for. So this underscore is just for readability purposes, right? So it helps us differentiate. It improves the readability. I'm saying 1 million here. It doesn't change this in any way. Still an integer, but it's 1 million. So okay, so it's 0.417195, right? So let's copy this so that we don't lose track of. I'll run it again.
So random seed is like one type of a barcode that is assigned to any certain pattern.
Yeah, something similar.
Means so, we can say that means it is the name of the pattern. We can say means any random name we are giving.
Yeah, exactly. So
yes.
the point is these are actually not random numbers in the true sense. These are actually pseudo random numbers.
Yes,
they are pseudo random number generators. So see the seed, once you fix the seed, it is still random, but it's deterministic in some sense.
Yes, sir.
Okay, so all right. So it's a very
any number as a seed, as in
you can have anything. So you can have 0. Typically, the seed is chosen to be some big number, so that if you are trying to use it, let's say for cryptography purposes or for some such reason, no one can easily guess this. So if you give something like 0, 1, or 2, that might be people can easily guess it and figure things out. So it's preferable to have the seed as some large number.
Sir, now that you've thought about random birth seed, how does it work, sir? I've been having this doubt for a long time, but I don't find it anywhere.
So actually, I also don't know much about random number generators.
Okay, sir. Okay, no problem.
Right?
Thank you,
So
sir.
we'll have to collectively look at some Stack Overflow site. I think that will give us a.
Actually, I did search Stack Overflow. The Stack Overflow doesn't seem to have a perfect answer for this. It's okay, sir. Thank you.
Yeah.
Sir,
Okay.
can we take a user input for random seed? Means
Yeah.
like can we take that?
Yeah, that also works.
Okay, sir. Yes.
Yeah. Problem 6 is.
Hello, sir.
Yeah.
Sir, seed can be alphanumeric character or only digit?
I think it has to be a digit. We can try. I don't think strings work. Oh, it seems to work. Maybe I was wrong.
Hmm.
Sit. Yeah, I think it works. So let's just look at it. So if you want to find what that function is about, you can use this help thingy here. That will. So what it says is, yeah, it seems very complicated. It's not telling us what the value of a can be. Okay, seems string is fine. Okay, I think you can take anything apparently.
Okay, sir. Thank you.
Yeah. All right, so we'll go to this math heavy problem. So we have the sequence xn equal to cos of xn minus 1 starting from 0. Okay, and so how many of you are doing max 2 here? I mean, a rough estimate I want to know. If you are already familiar with the limits and all these things, or okay. Okay, so decent number seem to be doing limits. Okay, fine, great. So you are like limits is be totally familiar with that, most of you.
But sir, I would suggest not to give such questions in the quizzes or exams, because then it will be a problem.
Yeah. So this is meant more for your. This is an activity question, right? So an activity question, we dump all sorts of interesting, unfamiliar questions. This won't come in exams because the idea of limit is not necessarily known to those who are taking only Python. So we won't ask these questions. All right.
Sir, during this quiz, will we get access to use Replit during exam?
Python quiz, I don't even
Yes.
know when it's going to happen. So you'll be intimated, right? I mean, we also do not know.
Zone 5 or 6.
5 or 6, I think all the exam will happen.
Right. See, even it may happen, or see the exam might happen, but we are not yet sure what type of environment will be there. So I can't promise
Okay,
you
sir.
that it will be Replit or it may be something else also. So I'm not like really sure about that.
No problem. Okay, sir.
Yeah.
Thank you, sir.
Okay. So we'll do this limit question now. So from math library, we'll import this cost function. And what we have to begin with is x equal to 0. And let's try this for say 10 steps, right? So x will be nothing but cos of x. That is the idea. You take the previous value of x, cos of x, that will be the new term in the sequence, and you keep doing this. Let's see what happens at the end. So you get some value like 0.731. What about 20? 0.7389. Let's move it to 50. Okay, so we are getting close to some value, right? And by this time we are like pretty close to the actual limit, though we don't know what exactly it is, but this is an approximate value of the limit of the sequence, or
Sir,
whatever.
why we are using the for loop?
Yes.
Yeah, I'm coming to that, right? So here for loop is not the right thing, but this is just to show you that.
No, sir. We are not changing inside for loop anything.
Yeah, we are assigning the x value only.
X
So
equal to cos x only we are doing. Nothing I'm doing.
Yeah, so that is the question, right? So xn equal to cos of xn minus 1. So the previous x value, I am going to plug into cos of whatever, and that will be the new x value. So we keep doing that. So this is
Okay. I got, yeah.
right. Actually, here for loop is not the right thing, but for a different reason. So if you notice the question asks us the following. We want to use this particular tolerance between successive terms to terminate the sequence or the iteration. Okay, so what I mean by that is, let me print the values in the sequence, and then we'll get a better idea. So if you notice, as the sequence gets closer and closer to some limiting value, the difference between successive terms becomes smaller and smaller, right? So here it was quite large, nearly 0.25 or 0.3, and here it came down. Here it's much less. Finally, here if you notice, it's almost indistinguishable, right? So the idea of a tolerance is to tell you when to stop the iteration. So when two successive terms, if the difference between them is very small, then you are going to stop the iteration. So in such a scenario, for loop is not the right way to go, right? So while the difference between the previous term and the current term is greater than the tolerance, you are going to keep iterating. Okay, so I'm going to define a previous and a current. So this may be slightly tricky if you have not seen this before, but don't worry, this is like not a very important problem to know. Okay, so what I'm going to do is I'm going to write the code, and then you can tell me if you understood it or not. If you don't understand this, please don't worry about it. Okay, I'll also count the number of iterations.
So shouldn't it be cos of x previous?
So see, what I'm doing is cos of the current value becomes the new value, and whatever is the existing value, it becomes the previous value.
Is that because you've written all in one line, sir? Had it been in two different lines, it would have been different, right?
Yeah. So I'm the way this is happening is it's simultaneous assignment. So
okay.
This goes into this goes into this, but it happens simultaneously. All right. So it seems did you all get it, or this is like, if it is too confusing, we actually can leave it here, because it's like a bit tricky, this particular problem. Anyone have any questions? Is there any part of this which is not clear, which you would like to go over?
Sir, does the
How are we
number of
initializing?
How are we initializing what?
I mean, the values 10 or 0. Is it random?
Yeah. So this is, see, the reason I'm doing this is I just need to get through the first time. I need to get into the loop the first time. So if it is 0, right, what will happen is I won't even get into the while loop. So I want to avoid that. So I give a sufficiently large number. It can be any large number so that I get once into the while loop. That is why I'm doing this initialization. Okay, so one,
Sir,
yeah.
the number of count won't change for number of x and x current, right? Means even if it is 10,000, it remains 30. If it is 1 million, it remains 30. That way.
Yeah, exactly. Yeah, count won't change because of the initialization.
Okay.
Okay, so I will leave it at this. What's the purpose of count in loop? So the count, it tells you how many times the while loop is, how many iterations it takes for you to arrive at this limiting value, right? So sorry, in this case, we know that it takes 30 iterations. That's the purpose of count. That's because later on I added one question, how many iterations are needed to achieve this? Okay, so you can have a look at the solution that is, we'll be putting it up very soon. And if you have any doubts, you can ask. So for those who are mathematically inclined, so did anyone get this answer? What is the connection between this question and this graph that is drawn here? I mean, it's perfectly fine if no one got it, but I'm just curious to know if someone figured out this connection. Okay, yeah. So this is, I mean, it's totally a question out of the blue, right? So see, this particular red color curve, can you guess what it is based on this question?
Cosine.
Okay, so this is cosine.
Cos theta, sir.
Can
Cos
you
x.
can you guess the blue color thing?
X, sir. F of x
Y
is
equal
equal
to
to
x.
x.
Okay. So then what do you think this point will stand for? This particular point?
Sir, at that value of x, the value of cos and x is same.
Exactly, right? So
the value of y and cos x will be there.
okay, so this is actually solving this. Yeah, so Purnima is right. That's fixed point iteration. I mean, it's totally a new set of things. It's like for your own reference. This is one way to find the point at which cos x and x have the same value. Okay, so this is not going to come for the exam. You don't need to worry about it from that point of view, but I am just adding it so that you guys are aware of it. Okay, so the whole point of this question is to give you this idea that Python is used for numerical computation, right? It's heavily used for numerical computation, and it's not just for sorting numbers or such things alone, right? So this is the power of software like Python, right? Okay, so we'll move on. This is kind of mathematical. I don't want to bore you with too much maths at this stage, so I'll come to this at the end. We'll go and do some pattern matching. So we have to print this pattern 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we'll do that now. Pattern needed is 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, not just for this, but for any number which is divisible by 3, this is the pattern we want. All right. Okay. So how do we do this? Here a for loop is very useful. So what we'll do is we'll start from 1. We'll go up till n plus 1 because we need to go up till n. But we'll do so in steps of 3. Do we need to go in steps of 3?
If you go in steps of 3, it will be 1, 4, 7, 10 that way.
Yeah, so we'll go in steps of 3. So what we'll do is we'll print I plus 1, I plus 2, okay? And we will separate it by this thing here and see what we get to begin with. Okay, I'm running it and I'm not getting anything. So I guess I'll have to restart my Ripple.
No, sir, it's in input, so you have to give input.
Yeah. So this thing should disappear. So usually it disappears, which means it's stuck. So if it disappears, then yeah, okay. Okay, so we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, all is fine, but we are not getting the initial thing here, and we are having a space here. So can someone tell me how I can remove? I need to remove these spaces, and I need a opening thing here. So anyone, any ideas?
Sir, using the
Sir, we
SEP
can
command.
use a different format of printing, sir. We can use the different format of printing. And sir, I have another doubt. What is the difference between end and separate?
Yeah, so we'll just finish this. So yeah, so
Comma we can remove and we can use that format, sir.
yeah, that is one solution. So we'll use this sep command first. Okay, so this will remove the spaces. Okay, and to add the initial thing at the beginning, what we can do is we can just do this, right? So this will give us the required pattern. Maybe we can add a print at the end so that it comes to the new line. This, otherwise it will keep hanging here. Okay, so this is one solution. Now for other solutions, can you give me some other solutions?
Sir, I have done it with by checking the multiple of 3, like dividing the number with 3 and checking the remainder.
Okay, so that is also valid. And the actual printing?
For printing, I have just inserted the line as a string after every multiple.
Okay, so let's
Sir,
also try.
instead of getting the user input as an integer, why can't we get it as string? I mean, there is no point in getting it as. There is no difference also.
I mean, you need an integer,
It
right?
also
That
makes
is...
the makes the mission easier.
One
So
thing
the
we
user
can
will
do,
know he's giving an
sir.
integer, but we only.
Okay. Yes.
Can I say, sir?
Yeah.
Suppose I'm taking the number, I have to print the 3, 3, 1, 2, 3. After that, vertical, then 4, 5, 6. No. Why don't we put the string as the 1, 2, 3 together in one string? Then after that we can partition also.
Yeah, that is also fine. I mean, you want to define, let's say, a new string called like this, right? Is that what you mean?
Yes.
Yeah, this also works. We can do this. So in that case, we'll have to do so let's try and see if this works.
No, X will come in curly brackets.
Yeah, I'm sorry. This is okay. Let's see if this works. Okay, we are having a extra.
We need to remove the end, sir. No? We can remove end.
Okay, but that would get printed. We can maybe remove this.
At the last we can print it. No?
Yeah.
At and the last we can print it.
Yeah, yeah. This is fair enough. So this also works. Okay. Yeah. Yeah. This is also fine.
Sir,
All right.
can I give a suggestion?
Yeah.
So instead of putting x is equal to string of I plus string of I plus 1, instead of that, you can get all the user input as string, and in the place of range, you can use int of n plus 1, like no.
You want to accept it as a string, huh? Okay.
So you want me to repeat again?
And then do what?
Yeah, instead of n plus 1, you can use int of n plus 1.
Okay. All right.
You can remove all of sixth line.
No, right? Their I is still not a it's still an integer only. Even if you replace this by int of n, I is still an integer.
Sir, for I in n, sir, for I in n, not range. You can use for I in n.
Okay, but that won't work, right? I mean, okay, since you are telling, I'll do it, but how will this work? It will throw an error.
Sir, you can create a new variable. You can create a new empty variable, I mean empty string, and you can append to that.
That is right,
after
but,
every 3 steps. You can add this straight line, and you can append to that new string.
yeah, so that is correct, but this for loop is wrong, right? I mean, this won't work, no?
This will
So
also
for
work,
not
sir. If
I in n, sir, for I in n, you can put I in n. You can
Yeah.
remove int now.
Okay, so yeah, this is a string, so you can iterate through the string, but okay, I'll just, maybe I'm not getting what you're...
After every 3 steps, you can use another for loop. After every 3 steps, you can add that straight line.
Yeah, so just give me one second. So maybe so if I print just this, right, what do you think will happen? Say if n is 10, what do you think will happen?
no, sir, it will only one time it will come.
Yeah,
it is
it'll
10 is only
So
one
it will
number.
print 1.
Yeah, it will only print 1 and 0, right? 1 on the first line and 0 on the second line, right? So
yes, it will print 1 on first line and 0 on second line.
yeah, but this is what we want, right? So
Sir, now we can use that end is equal to empty things in the end of a print line.
see,
It will print in the same line.
see, if I enter 9, I am only going to get 9 because 9 is a string now. So I need integers to help me here. Without integers, I cannot operate.
Sir, we can do one thing. We can start a empty string.
Okay.
S equal to in the before for loop.
Okay.
And not with vertical the slash. Yeah, inside the string. Yes, and in the for loop, I in the range of int n.
Yeah, so that's right. So once we come to integers, there's no problem. So that is similar to the previous solution, right? There it's as good as having int of n.
Sir, this is
and then
exactly
n.
what I said, sir.
And start with 1, sir.
Yeah. So see, I understand perfectly what this solution is clear. So what you are telling me was to remove this whole thing and just iterate through the string. That won't work, is what I'm saying.
Yes.
Okay, so this won't work, but this is perfectly fine, man. So this will obviously work, right? So see, my point is, without going to integers, you can't solve the problem.
Yes, we can't.
Right. So that is all I'm saying. I'm not saying this is wrong at all. So you're perfectly right. But at some point you'll have to do if you don't do int of input here you have to do int of n. Okay.
Yes, sir. I agree with that too. I agree with that.
Okay, so that is all I'm saying. It's not that this is a wrong solution, but yeah. Okay, so we have to move on. This is just the multiplication table, and that we have to print. Okay, so let's. What we'll do is we'll first print the first line.
Hello, sir.
Yeah.
So I have a doubt in week 3. So should I wait till the end?
Yes, I'm sorry, because this is for the activity session. So
yes, sir, I understand that. Yes.
Yeah, okay. Okay, so this is just printing 1 to 10 with tabs in between. Okay, so we need to do this 10 times, so we'll do just that. Okay, and we'll maybe change this to j. So this will just print 1 to 10, 1 to 10, 10 times, which is not really what we are looking for. All right. What we actually need is every row we need to multiply this by the corresponding number. So we need to print I times j, right? So that is what we need. So we get 1, 2, 3, 4, 2, 1 stable. So the 2's row, 3's row, 4's row, so on. Okay. So we have this section of the output in place. Now we need to add this row and this row. Okay, let's go ahead and do that. So for the first row, we can just print this all over again. Okay, so that there might be much better solutions, but I am just going with whatever comes to my mind right now. So you can, once I finish this, you can share your solutions. Okay, so this needs again another end. Okay, so we have this first row in place. What we are missing is the column here, right? So will this work? Okay, I think that worked. Okay, so any questions here? So this is exactly, I think, what we want printed here. So is there anything here that you didn't understand that we need to go over? Okay, anyone, any doubts? Or shall we move on?
So the first line is only for that first tab that is there, right?
Yeah, exactly. That's only for this tab. This.
Okay.
Yeah. Okay. So if there are no other questions, we will move to this question. So I don't know if you'll be able to finish all 25. Let's see. Okay, so what we are doing in this question is we are adding coins to boxes, box 1 all the way up to box 5, and then we'll cycle back and add coins to the first box. Right, so how are we going to do this? We are going to do this by accepting a string as input. Okay, so let's do it the following way. So coins, that will be our input string. Okay, so what I will do is I will have a list of, we have a list of boxes, right? So for I in range of 5, there are 5 boxes. Initially, all of them have 0 coins. Okay, so we have now created 5 boxes with 0 coins in each of them. Now we'll go through each coin in the coins. So I'm going to introduce a new way to do this. I will explain what this is. Okay, so this is the, so I'll just, maybe I'll print this so that you understand what this is doing. Okay, I'm copying this set sequence of coins. So if you notice, this enumerate function here enumerates or lists down the index along with the element in a particular sequence. So for example, at the 0th place we have coin 3. At the first position we have coin 9. At the second position we have coin 7 and so on. And at the 9th and index 9 we have coin 0. So this is sometimes useful. Instead of using the range function, we can use this if we want to know the index and the element in the sequence corresponding to that index. Right, so I just explained that what enumerate does is it gives you the index of a particular element in the sequence and the value in that sequence corresponding to that index. Okay, so that is what enumerate does. So why is this useful? Okay, so what we need is, if the index is 2, then we'll have to add this coin 7. We'll have to add these 7 coins to the third box. Okay, so that means we have to add it to box index plus 1. All right. But the problem is, let's see how it works. So if it's 0, index is 0, then I'll add it to box 1. If it is 1, I will add it to box 2. If it is 4, I will add it to box 5. So I need to cycle back, right? So for this, what I do is I take the remainder when I divide this by 5. So does that make sense? Yeah, just go ahead and write this code, and maybe later on we can have the discussion. See, someone is asking in the chat, this is not introduced in the lecture. Of course, I just mentioned, right? So this is not introduced in the lecture, but I'm just introducing this to you now, right? There's no need for you to worry that this will come in your exam. I perfectly understand that you are new to programming. I'm not saying, see, where else do you introduce these things? So there should not be a block for introducing things, right? So just because it has not been introduced in the lecture, it doesn't mean that we should not use it during these sessions, right? The whole point of these sessions is to expose you to new things, right? So stop while you are doing something like this session, right? I would please request you to stop thinking from the examination point of view, right? So this is something that you can even forget for as far as your exams are concerned. But please be open to the idea of seeing new commands, right? New things. I thought that you guys would be actually happy to see something new, but please have that kind of a mindset. Otherwise, it'll get a bit difficult. Okay, so what I'm going to do is I'm going to add this coin into that particular box, right? And let's just see if it works fine so far. Okay, so it says 12, 13, 16, 3, 8. Let's see if that is the correct thing. It's 12, 13, 16, 3, 8. Okay, so I will stop at this stage, and I'll request you to go over these 3 lines of code. If you want me to explain enumerate again, I'll explain.
So can you go and can you let us know how that 7, 8, 9 works actually? It's a little confusing there.
Yeah, exactly. So see, if these things I'll certainly do, but whenever something new comes up, right, I would please request you all, I'm not targeting this at anyone, but please don't black out, right? I mean, I know that some of you are new to programming and you're seeing things for the first time. See, it's very simple for me to write this using range, but this is much more elegant way of writing it, right? So that's why I'm introducing this to you, and it's not as difficult as it sounds, right? So what I'll first do is I will comment this whole thing out, and I will just introduce this enumerate. I'll comment this also so that you all get an idea of what. Okay.
Sir, also please re-explain the concept of enumerate. I missed that question.
Yeah. Okay, so let's say we have, that's what I'm doing now. So let's say we have a list of elements, say 10, 20, 30, 40. Okay. For I comma element in enumerate of L, print I comma L, sorry, I comma element. I'll just run this. I'll comment this also. Let's focus only on these 7, 8, 9, these 3 lines. Okay, so enumerate is as simple as this. It returns a pair of numbers, right? In this case, I am calling it I and elem, ELEM. Okay, so I is nothing but the index of the element, index of the corresponding element. So for example, there are these 4 elements, 10, 20, 30, 40, and 0 is the index of this first element, 1 is the index of the second element, 2 and 3, right? So that is the whole point of enumerate. Okay. Okay, so I'm getting
It's like a key value in dictionary.
Yeah, so since you are all not, so I think you all have a problem. You think that this is stopping you from problem solving. So what I'll do is I'll ignore this enumerate, forget about this. I'll show you that this is not stopping you from solving the problem. Okay.
Are we okay with enumerate? But how does this 8, 9, 10 work is what I'm not getting. Box index is equal to index plus 1 mod 5 minus 1. What is it doing basically? Is it
Yeah.
giving a designation for the boxes?
Yeah, 1 second. So I'll just, since this caused too many problems, I'll just move to the more difficult way of solving this, which is like this, right? So this only makes life more difficult, but it's fine. Okay. Right. Okay, so let's not accept input, or let's, for the time being, what we'll do is we'll copy this so that we don't have to keep accepting input. Okay, so I will also take this opportunity to add some things here. So this goes to box 1, this goes to box 3, so 2, 3, 4, 5, and then it's 1, 2, 3, 4, 5. So this is what we want, right? This is what we want to observe. I mean, this is how we want to add things to the boxes, or this is how we want to add coins to the boxes. So how do we do that? So coin will be, let's start with the first index equal to 0 is how we start, right? So 3, coin is equal to 3. It has to go into box 1. Okay. So since index is 0 to begin with, what I'm going to do is I'm going to say index plus 1. That is the box into which the coin has to go into. Okay. And for index equal to 2, for index equal to 1, it has to go into box 2, right? So that is why I keep adding 1 to index, so that when I come to the 4th index, I'm actually going to add to the fifth box, right? So that is the basic idea of doing index plus 1. But when I go to the 5th index, right? So this, remember, this is the 5th index because we are 0 counting. When we go to the 5th index, we have to go back to the first box, right? So one way of doing that is, if you remember the Caesar cipher lecture that the prof covered, if you take the remainder with 5, you will cycle back to the first box. Do you get the idea of why we are doing modulo 5? So is it clear, or is this part clear why we are doing index plus 1 percentage 5?
Yes, sir.
Okay, so it's kind of slightly tricky. So what I will do is I will delete all this and I will write it again. We will just do this. I will just write this so that it becomes clear. Coin has to go into, let's now run this. Okay, so 3 has to go into box. Okay, 3 has to go into box 1, that is clear. 9 has to go into box 2. Till 8 has to go into box 5, it is correct. Okay, but 9 has to not go into box 6, it has to go into box 1 again. Okay, so what we do for that is, we are going to take the remainder when you divide index plus 1 with respect to 5. Okay, now let's see what we have. Sorry, this has to go into okay, so 3 has to go into box 1, 9 has to go into box 2, so on, and now we see that 8 has to go into box, we are getting it has to go into box 0. Okay, because box 5, when you come to box 5, when you divide by 5, the remainder is 0. Okay, so to get around this, we subtract by -1, and you will see why this is a useful thing to do. So remember that boxes is a list, right? So if you say the box numbers are 1, 2, 3, 4, 5, in the list the index is actually what? 0, 1, 2, 3, 4. And if you notice, index 4 is the same as index -1. Okay, so just see what has happened. 3 has to go into box 0. I mean the index of box 0. 9 has to go into the index 1 of this boxes list. And finally, 8 has to go into the 5th box. But as far as index is concerned, in this list, it is index 4, which is the same as -1. So is this clear now?
Yes, sir, it is now. Thank you.
Yeah. So I'm sorry if this enumerate kind of confused some of you, but the intention was not to make life difficult for anyone, right? So intention is to introduce you to new things. Anyway, so index, so this is what is happening, index plus 1.
I think the confusion was here with the -1.
Yeah. So yeah, that can be a little tricky. So the -1 is just to make sure we have the correct index in the list boxes. Okay, so this is the, I'm going to call this the box index. Okay, so once you have the box index, you are going to append, or you're going to add this particular coin to this particular box, right? So this has to be an integer. Now we can print the boxes and see what we have. So 12, 13, 16, 3, 8, that is what we have here. 12, 13, 16, 3, 8. Finding the maximum number of coins, I leave it to you. It's like, you would have seen it a lot of times in CT. It's a very simple line of code. Okay. All right. So I'm going to move on since we are severely out of time. Yeah. So consider a bouncing ball. It's going to be dropped from the height of 10 meters. And every time it bounces, it's losing 1/10 of its height, right? So in a simple piece of code, we'll just go ahead and write this. So you are starting from a height of 10 meters. Okay, so every time you bounce it, it's going to lose 0.1 into that height, right? And since you start with height h, it's going to rise to h minus 0.1 into h, which is nothing but 0.9 into h. Right, so this is what is called the rebound height. So this is how high it's going to rebound. So now we have a simple formula. So every time the ball bounces, it's going to rebound to a height of 0.9 times the previous height. Okay, and now the question is asking us to find when the height will come below 1 meter. Okay, so as long as height is greater than 1 meter, I'm going to keep bouncing it. Okay, and initially there are no bounces, but every time I enter the loop, it's going to bounce once and height is going to come down to 0.9 h. Finally, we'll print the number of bounces that were needed. Okay, again my replit got stuck. Okay, so it says 22 bounces. Let's try this out so that let's print the value here so that you understand if it is the right thing or not. Oops, that is printing too many things. So what we'll do is I will just make sure I print only 2 decimal places. Okay, I'm sorry, I'm going to have to restart my REPL again. Okay, not needed. All right, see, okay, so after the first bounce, why is it printing 9 2 times? I don't know. Okay, for whatever reason, it's printing this twice. I think it's a problem with Replit. Anyway, so yeah, so after the first bounce, it rises to a height of 9 meters. Okay, after the second bounce, it loses another 1/10 of its height. It bounces to a height of 8.10, and after 21 bounces, it still bounces to 1.09 meters. So we are not yet done. So it is only after the 22nd bounce that it goes below 1 meter. Okay, so it takes 22 bounces for it to go below 1 meter, and that's the value of count. Is it clear? Is there any aspect of this code which is not clear?
Clear.
All right, okay. Yeah, so that is this. This is again simple. I'm going to leave this question because this is quite simple. If there are doubts, we can come back later. Okay, so just give me 2 minutes break. We'll resume just after this 2 minutes. Okay, let's resume.
Sir, how do you come up with these questions? They're really innovative questions, I would say. I mean, even if you check in Google, you wouldn't get answers to any of these.
Yeah, so thanks. I would take that as a compliment. So the thing is, these are all, some of them are from personal experience. So for example, this is there in a 12th standard max textbook. I mean, when I was in 12th standard, sorry, 11th standard, this was one of the questions there. So some of them are from personal experience, and this is also a game that I played when I was very young. So, and a few other questions, they just kind of sometimes it's personal experience, sometimes it's a nice observation. So, for example, this math-based question is. Uh, I saw it in one of the websites, so it's not like all original questions. So some of them are stealthily, quoted from some websites. We just don't mention it, and we just take it as you guys assume that it's our questions. So that also happens, and that is the brief history behind these problems. Yeah. Okay. So I am currently on Ubuntu. It's a simple uh, machine which runs Linux, right? Yeah. Okay. What we will now do is, this NIM is a very interesting game. So the way it works is, there are n marbles, and two players are going to take turns to play the game, and each player has to remove at least one or at most four marbles. So the computer and human, these two are going to be the players, right? So let's go ahead and write a very simple looking, I mean, not simple looking, we'll start with the basics and we'll see how it goes. So clearly there are going to be two players, right? So one will be the computer and the other is going to be the human, right? So these will be integers that will be in the range 1 to 4. All right. So, okay. Now for making the moves, as far as the computer is concerned, we need to simulate it, right? We need a random number generator. And the computer's move will essentially be something like this. So random.randint of 1, 4, right? So it's going to pick up something from this range, and that will be the value, right? So let's now begin with the number of marbles that our game is going to have. This will be the number of marbles that we are going to play with, right? So there is one more thing that we need to know. Every time a move is made, we need to know who is making that particular move, right? So let's have a variable for that. So once the computer makes a move, the next turn is the human's turn, right? So we'll denote this using a variable called turn. All right, yeah, we can even use 0, 1 for humans for the turn. It can be a Boolean variable essentially. Okay, so while there are still marbles left in the game, we need to take turns and play. Okay, so if the turn is the computer's, what will happen is the computer will have to make a move. Oh, 0 is missing for humans. Oh, thank you. That is what you meant. I'm sorry. I didn't understand what you meant earlier. Okay, so if it's the computer's turn, then the computer will pick up a number at random from 1 to 4, and then it will become the human's turn, right? If it's the human's turn, what the human has to do is, I mean, we are going to play, so we'll have to accept an input from the user. Okay, so let's just say that enter user's turn, right? So user will have to input a number from 1 to 4, and then it becomes the computer's turn. Okay, so if you notice, what does a turn mean? In a turn, what happens is whatever is the value of whatever is the value chosen by either player, that number of marbles is removed from the pile. So that is the same as doing n minus equal to computer. And as far as the human is concerned, right? So this is the basic logic behind the whole thing. Okay. And as far as the winning strategy is concerned, I'll just delete these things are not needed. Someone has to start, right? So I'm going to simply assume that the computer starts first always. Okay, so I will repeat the following. So computer will pick up a number at random, and then that number will be subtracted from n, and it will become the human's turn. Okay, so do we actually need to do this outside? I think you don't need to do this outside. Just excuse me. So you can as well do it inside as a part of the loop. We'll just specify whose turn it is. Let's say it's always the computer's turn to begin first. Okay, so when the number of coins becomes 0, that means the game has ended. So we'll have to declare who the winner is. So if n will anyway be 0 because you have come out of the loop. Now if it is the computer which made the last move, that means it is the loser, right? So if the computer made the last move, then the turn would have become the humans. So if the turn is human, you'll have to say that you win, right? I mean, if anyone is not clear with this, let me know. And if the human made the last turn, right, he would have removed the last, or he or she would have removed the last set of marbles, and the computer would be the winner in that case, right? So if the turn is computer, you have to print. Okay, is this winning condition clear to all of you? Why we are doing it this way? Okay, I hope it's clear. We will play a few games and we'll know. Okay, so one more time. So what's happening is, let's say there are 3 marbles at this iteration of the loop. We enter the loop, n's value is 3. Okay, so let's say it's the computer's turn. Now the computer picks up 3 marbles, right? It picks up all 3 marbles, and according to the game's rules, the player who picks the last set of marbles, that particular player is the loser. So the computer loses in this case. But notice that after the player makes his or her move, it becomes the human's turn, right? So whenever the computer makes the last move, the turn will point to the human. So a human naturally will become the winner. All right. So I hope it is clear now. Okay. So there are a few mistakes here. Can somebody point out what these mistakes are? Can you identify any flaws in this code? I have deliberately missed a few things. Okay, I won't say break is the thing which is missing. Okay, I'll just give you this hint, right? So what happens if there are 3 marbles and the computer makes 4? It tries to remove 4 marbles, right? Or if so, that's a possibility that we have to check against, right? So if computer, whatever move made by the computer is greater than n, right, then what I'll have to do is I cannot continue, or rather I have to continue to the next iteration because I cannot move ahead with this move. So I'll just say go on, once again get an input from the computer, right? So I'll have to do that. Okay, so this is something that's missing. So now what
when
we
you
will
say continue, it will pass on to the human. I mean, the human would be passed and then come back to computers, right? That is what is going to happen. It
yeah,
will
so
skip one, right?
it will skip the entire thing below line 12 and it will move, it will again ask input from the computer.
Okay, okay.
Okay, so let's just add this. Marbles remaining, we'll add this in both the places just to give us an idea of what is happening. Okay, and we'll also do the following. Computer chose these many marbles, right? So that is something we need to tell the user, otherwise we won't know, and we can still know, but yeah. Okay, so let's just try this. Let's play this game for 25 marbles and let's see what happens. So the computer chose 1. What we'll do is we will choose 3. Okay, so marbles remaining 21. Okay, computer chose 2, so there are 19 marbles remaining. So what we'll do is we will choose 4 this time. 15 remain. Computer's choice is 1. 14 remain, so we'll choose 3. Okay, so marbles remaining 8 because of the computer's choice, so we'll choose 2. Okay, so marbles remaining 6, computer chose 3, so 3 marbles remain. So what I'm going to do is I'm going to choose 2. Computers chose 1. Right, so we have, so yeah, why am I not, I'm currently, it should say that I won the game. Okay, so why am I not getting anything here?
Sir, it should be LF when the turn is equal to human.
Sorry, come again.
Sir, turn is equal to human now. There, instead of if, it should be LF. Else if.
Not needed, right? I mean, if it is.
No, sir. That's why it's asking for the user turn, because after going into the first, if condition, computer chose, but when it come out, it again checked for the condition of if turns is equal to human or not. So there it should have exited because there is no marble remaining. But since it is if turn equal to human, it is getting executed.
See, marbles remaining 0, right? So when it is.
We can do one thing, sir.
Sir, try once, no? Instead of F, just try LF.
Where you're saying here, is it?
Yes.
Okay, but I am still not convinced by the reason for using LF.
Sir, after the turn gets into human, it moves into next if.
Yeah, that's what I'm trying to say.
And if that is elif, that will come into while again, and that will exist.
Otherwise, you have to put this condition also. If turn is equal to human and marble, the number of marble, then n is equal to n is greater than 0. That condition you have to put. Otherwise, you have to put else if.
Okay, so what I will do is I have done this without using else if. I'm just going to refer to my own solution one more time. See, the reason is you don't need the else if. That's my point. Let's see what is happening.
The current code is also correct. You just have to change the condition. That's it.
So in this code, the computer is coming in the second if, and on that code that was on the first if.
Okay, so you're saying that the order of the code is the problem?
Yes, sir.
Okay, I will change that. Okay, let's now try to run this for a short number of marbles, right? Okay. So can somebody explain? I still didn't get the point. Why we need else if?
Sir, just try once, no? Then when you run it, you will understand.
No. Can you explain here? I want to know without running it. I mean that
because in this case, when marble is number of marble is 0, it is not asking for input. Means there is no if condition after the computer's turn. In the previous case, there was a if condition after the computer's turn. That's why it was not exiting.
Oh, okay. So we are not. You're saying we are not asking for. Oh, right. I get your point.
That's why I said if you put if else na else if na, then also that will work. The previous code.
Okay.
Yeah.
Can you please elaborate on that? I mean, it didn't.
So his point is, if the last turn is the computers, if the last turn is the humans, right? So the next turn becomes the computers. But still, if the computer chooses particular value, n should become 0. I'm still not convinced.
When n is greater than 0, the while loop will stop, right? I mean,
yeah, that's what I'm also looking at. So I'm just going to go back to my. I'd like to debug this a bit further. So please bear with me. I want to see what is happening. Why the earlier code didn't work. So it's printing.
So in this code, after n becomes 0, there is another if. It is not coming back to while. Because now turn is human, and it is not checking n greater than 0. It is going to next if.
But that could happen. That could happen the other way around as well, right? If you replace.
No. In the other way around, the second if was the last if. So after if executes, it comes back to while. There was no code after the previous one.
So in this case, if suppose a human was the last one to choose, then in that case, it would say that you won. I mean, the computer won, right?
No. In the case, it is saying the human is last one to choose, but it is not checking the n now. See, it is becoming n minus 1 equals to 0 now.
Sir, if you want to check the turn of human, means after the computer's turn, either you have to check if n is greater than 0, or you have to put the condition else if. That then only it will work. Otherwise, it will not.
Yeah. See, my point is what I don't understand here is.
Sir, print the n before if turn equals to human. You will see there will come 0.
Yeah.
Yeah. Okay. So. Okay, let's run this for 5. Okay, so marbles remaining is 3. So it's printing.
Yes, see, the value is 0, but you are checking the human's turn after that. That's why you have to check only go into this condition if n is greater than 0.
Okay. So yeah. So this is right. I get the point. So what's happening is now I understand why you were suggesting else if all along.
Yeah.
Or sir, if we could just write turn equal to human and n greater than 0.
Yeah, that
then also it will work.
Yeah.
Now I understand. Yeah, very nice. Okay. So I was under the impression that turn is always going to be this binary value, either computer or human, and we may not have to use the else if. So Now I get the idea.
Can we avoid n greater than 0 if you use else if?
Yeah, so in that case only, but yeah, let's just think about it. If else if alone solve the problem, I think it will still keep accepting input from the human. Let's try it out. User's turn. Okay. Yeah, I think else if alone is enough then. This computer is always choosing 5. Right? Every time I do, it's choosing 5. I have not set any random seed, right?
Previous condition was good, sir. The n is equal to n is greater than 0.
Yeah, this fellow is choosing marbles remaining 1. Yeah, so the else if alone is enough. Okay, that's a very good point. Thank you for pointing it out.
And we can make, sir, this game so there will be chance computer will win.
Yeah, so there is actually a way to make the computer win always. So, for example, you have to choose one more than multiple of 5, as somebody is pointing out.
Yeah, many possibility will be there.
Yeah, I mean, there is always a value. There is a way to. So, for example, if it's slightly complicated, but the idea should be one more than.
Actually, I made this same game, sir, on the JavaScript to visually see same logic.
Okay.
Sir, here also, if you change the n rand it 1 4 to n plus 1 and 4, then I think it should also work.
N plus 1 and 4, is it?
No.
I made that one complete, sir. Can I send you link?
Yeah, sure. Post it. You can post it in the forum so that everyone is able to see it.
Here I'm sending. Okay.
All right. Okay, so maybe we have time for just these 2 practical problems, and then we have to move on to. So we'll go to turtle demo. Okay, so I just copy whatever code was given here. So we have to print this polygonal pattern. I will just paste this here and run it. Okay, why am I not getting any output? Let's try again. Okay, so for whatever reason I'm not getting an output at all. Just give me a minute. I will just. Let me just create a new REPL. That token on line 2. What does that mean? Okay, I don't know why it didn't work earlier. Okay, so this initial set of commands are just to, get the shape of the turtle, and it's meant to import the turtle, and you can ignore these lines, right? So lines 3 to 5 are not that important. What is important is how to move the turtle. So t dot forward of 100 will move the turtle by 100 units forward, and this is the angle by which you are going to rotate the turtle. So for example, if it's 90 degrees, it will rotate the turtle by 90 degrees clockwise. So it will move forward and then rotate the turtle by this much. So if you want to construct, let's say, a square, what we can do is we can repeat this 4 times, right? So that way we'll end up constructing a square. So this is one nice use of loops, right? So instead of doing this so many times, we can just do it once, right? This will keep going on and on because I have not implemented count. Okay, so this is all we need to do for a square, right? So what happens if we have to do this for any polygon? We have to do a simple calculation, which is nothing but if there are n sides, then you have to divide 360 by the number of sides. Okay, so let's say if we want to do a pentagon, then it will be something like this, right? And instead of doing it for 4 sides, you'll have to do it for n sides, right? You will be moving forward by 100 units. There's no change there, but your angle by which you move is going to change now, right? So it's as simple as this. So if you want to do it for a hexagon, that will also work. All right, so there is there's one small question that I would like to ask here. So if I want to, if I make this, let's say 100, can someone tell me what will happen? What you will observe on the screen?
Circle most likely.
Circle.
Exactly, right? So let's just try this. Yeah, 10 steps is also too big. So let's try. Okay. So not 100 is fine, but we will move forward by only 1 step. Yeah, so this happens because of some floating point issue. So you'll have to enter a multiple of 60 so that it completes the whole turn. I still don't know why it works for multiples of 60 and it doesn't work for multiples. It doesn't work for other numbers. It's a very curious thing. You can try it out and tell me if you have an answer. I think it has something to do with why the way 360 is divided by n, right?
Is it because it is a float, sir?
Yeah, that's what I also feel. As long as it's a proper integer, it works really well. But the moment it is, so maybe I think even for 150, it doesn't have a problem, I believe. No, it has. Anyway, so that was just a small observation. So that's how you do this polygon. So how do you do a spiral? So we have a way to draw a circle directly. And matter of fact, that is, the circle is also
Sir?
essential. Yeah.
Sir, if we use angle float division, then it maybe works. I don't know.
Okay.
You can try it.
Maybe, yeah, maybe it might. Can try. I don't know. Maybe for whatever reason, I think it doesn't doesn't work well with floats for whatever reason, right? Okay, so this prints a semicircle of radius 50. The part of the semicircle part is here, right? So it goes through 180 degrees. So if you type this as 360, it will go through the entire thing, right? But for the spiral, what we need is semicircles of increasing radius, right? So how do we get a spiral? So we'll start with, let's say if we start with a radius of 50, then the spiral has to become bigger at some stage. So this has to become, let's say 60. So that is how you get the second arm of the spiral. Okay, and then you need one more step. Okay, that will that will make it even more bigger, right? So clearly this can be done much better, in a much better way using loops, right? So let's go through, say, 10 arms of the spiral, and in each arm we are going to increase the radius by a factor of n, let's say, not a factor of n, by n, let's say, right? Or n into 10. So we start with a radius of 5, and then it will become 5 into 1, 5 plus 10, then it will become 5 plus 20, and so on, right? So should not forget to increment n and start 0. Okay, so that was the turtle program. I would really encourage you all to try out more such snippets of code. It's a very interesting thing. I mean, it won't get you anywhere in terms of exams. Again, I'm going to go back to that statement. It will not help you in your exams, but life is not all about exams. So I would please remind you that other animals, yeah, I don't know if there are other animals. You can draw a ball. So actually that's an arrow. I don't know how to draw a ball, but yeah. Anyway, so we need to do a bouncing ball. That's the next one. So let's try that out. Okay.
Sir, can I draw anything use this import turtle?
You can draw your what you can draw is limited by your imagination in this case, right? So you can draw anything that for which you can clearly specify the coordinates. Like, so if you want to draw simple geometric shapes, you can certainly do that. If you want to animate more complex things, then you need to find a way of doing it using this. But you should be able to draw anything. I mean, of course you can't draw freestyle things, that won't work.
Yes, sir.
I have one question.
Yeah, please.
The spiral you draw that it's after semicircle we changes that you changes everything.
Yeah.
We change that, but really a spiral work like that every after semicircle, or that it's every moment it is increasing.
Yeah, perhaps every moment, but I just wanted to demonstrate this using every.
That's why I was thinking.
Yeah, maybe you're right. I'm not sure if it is every semicircle or every. I mean, maybe every moment it keeps increasing, probably.
Yeah.
All right. Yeah. So
we can implement every moment also.
Yeah. You can divide it into, so in that previous code, right? So you can divide it into finer steps. So for example, if you could do it in steps of 10, and maybe we can even try that, but it won't be, the radius should not increase drastically. So in angles of, let's say, 5, and we can try this and see what happens. Okay, this is too slow, maybe. Okay. Let's try 20. So there is a way to make it faster. I don't seem to remember the command. I don't think it's speed, but it should be something else. Yeah, but your point is taken, right? So you can go in smaller step sizes, or rather smaller angles, that would also work.
Okay.
So,
right?
Yes.
So I have doubt in the
Sorry, which question?
So we PPA.
Yeah, sorry. So we are we'll finish activity. Already we are running late. So I would like to do only activity today. Right. So we have an open session tomorrow. So you can we will
Open
discuss
session.
the PPAs there, right?
Okay, sir. Yes, sir.
Okay, there is a bouncing turtle. It's bouncing. It's not a bouncing ball. So maybe we have to go to. Okay, so this is how we do the bouncing ball. So when we do this pin up, it no longer draws anything. So I'll just show you what happens if you don't do pin up. It's just going to keep tracing this line. So you are actually moving the pen up and allowing it to bounce this way. Okay, so that is basically it for problem 16. Okay, so 17, I'll see if there are any interesting questions which we have to take up right away. Okay, so I'll probably do 24 now because it's one of those interesting questions, and we will get back to the others in a subsequent session. Okay. So 24 is what we are asked to do is we are given a grid world. This is called a grid world. So 1 corresponds to land and 0 corresponds to water. Okay, and if you are surrounded by water on all 4 sides, then you call that an island. So we have 2 islands here. Okay, the given a world like this, we need to find the number of islands. That is the question. Right, so the input will be just this matrix. In this case, it's a 5 by 5 matrix. Okay, so what we'll first do is we'll go ahead and accept this matrix as input. For that, we need to go back to that other ripple. So with this, mostly we'll be closing, but we'll at least finish this. So this is the size of the grid world. Okay, and so initially I'm going to say that this world is going to be stored in a matrix. I'm going to name that world. So for I in range of the dimension of the world, I'm going to append an empty list. So how are we accepting it? We're accepting it as a sequence of comma separated values. So what we'll do here is let me know if this is confusing, maybe confusing. But it's important to know this because this will come in your exams. Okay, I'll run this for this particular input and then you can let me know if you understood what is happening here. So are these 4 lines of code clear? 4 to 7?
So what is that world minus 1 dot append integer num?
Okay, right. So these are, I'm just truncating the whole thing into one single command. So what it's doing is in the ith row of the matrix world, you append this number, right? So this is the same as world of -1 because the most recently added row is the last row. So instead of using I can as well use world of -1. Okay, maybe what I will do is I will write the same thing in a different way, in a more elaborate way. Okay, you are accepting a row as input at a time, right? So I'll So world dot append create a new row, accept this row as input from the user. Now you are splitting it by comma. So each element in this row is now a string, but we don't want that. So in the ith row, you are going to append the integer version of the element. Is this clear? Is this 9 to 13? Is this clear?
Yeah, yes, sir. This
So
is
this is
better.
exactly what is happening here. We are creating a new row. Instead of having a separate variable called row and doing the whole thing, we are collapsing it into a single statement. We accept the input, split it based on comma, and then iterate through that list that we get. Okay, so I'll now delete this because this is more compact. Okay, now there is a nice trick that will solve this problem. I will let you know what the trick is, but did anyone solve this? Any ideas? We need to find the islands. So basically we need to go through the matrix and yeah, any ideas? Okay, Akshay has solved it apparently. Any ideas? Okay, before that I am having a question from Aisha. How is that matrix created? So see, in this line we are creating a new row in the matrix world, and in this subsequent line we are processing each row of input. So if it is if this is not clear, then maybe I will just make sure that it is in several lines so that for example, I just print this here so that you get a better idea. Okay, so n is 5 and the first input is 0, 1, 0, 1, 1. Okay, so row, I'm printing row here. So row is nothing but a list of strings. Okay, each row is nothing but a list of strings, but there is no point dealing with strings here. So what we need to do is for each element in row, I am going to convert that element into an integer. Okay, and where do I append this? To which list am I going to add this? I'm going to add this to a matrix, but to the ith row in the matrix. Okay, so now if you notice, I am not going to print the row, but I'm going to print the ith row of the matrix. You will, so now notice that they all become integers. So how only 0, 1 is coming? I'm sorry, I'm not getting the question. Yeah, so Akshay has given one of the answers. Okay, so yeah, I'm sorry, I have to proceed now because we will take the remaining questions later. So the basic idea is, see, if you want to get hold of this island, you essentially look at all these 4 directions, right? North, south, west, east. But here there is no north to look at, but still this is an island. So one way of doing it is embedding this matrix into a larger matrix, a 6 by 6 matrix, where all the elements are zeros. Okay, and in that case what will happen is you can use the same logic to declare that this is an island. You don't need to check for corner cases there. So I will just go ahead and write the code and you will understand. So there's a basic trick of creating a new matrix. I will call it modified world. Okay, so the modified world is going to be of size n plus 2. Okay, the reason is to the left I'm going to add one column and to the right I'm going to add one column. Likewise, to the top and bottom I'm going to add one more column. So the matrix will now be of size n plus 2 cross n plus 2. Okay, so now what I am going to do is, if I is in the range of 1 to n and j is in the range of 1 to n, then the world is essentially, the modified world is essentially the same as the previous world, right? So okay, so I'm going to have this might seem, this is, don't worry, such questions won't come in exam, so it's kind of you don't need to worry about the examination point of view. This is like a lot of code, but so can someone finish this? I'll append what inside this?
0, sir.
Okay, we'll append 0. So let's just print this and see what we have. Okay, so sorry it's taking more time, but we'll just finish it very soon. Okay, you will understand what I'm doing in a minute. So I'm going to copy this input. Okay, so if you notice, this is the matrix, so maybe commas, anyway. So this 0, 1, 0, 1, 1, if you notice, is embedded here, 0, 1, 0, 1, 1. Likewise, 0, 0, 1, 1, right? See, 0, 0, okay, where is that? Okay, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1. Okay, it's surrounded by all zeros around this. Okay, so that is the new matrix. Now, how will you check for an island? The way you will check for an island is for I in range of 1 comma n plus 1, for j in range of 1 comma n plus 1. If the modified world, if that cell has 1, then it could be an island. So in this case, we'll have to check for these 4 conditions. This is north. Okay, north is I minus 1 is the previous row. So for example, if this is I comma j, this is I minus 1 comma j. Okay, so we are checking if I minus 1 comma j is double equal to 0. Instead of doing that, what we'll do is we will finally say equal to 0. This is north. West is I comma j minus 1. Okay, so west is I comma j minus 1. East is I comma j plus 1, right? So this is I comma j plus 1. Finally, south is I plus 1 j. Why is that? Because this is I comma j, this is I plus 1 j. Okay, all these should be 0. If that is the case, then we are going to say we have found an island. Initialize, and finally we can print island. So let's run this. The answer is 2. Okay, so I'm going to stop here and ask, just ask you if you understood. If anyone has doubts here, we will discuss that and close the session. This might have been too much for some of you, but please don't mind. It's you can always come back to it later. Yeah, anyone, any questions? Or
Sir, a journal question.
Yeah.
Something from the week 1 lecture only, not regarding coding, but other than this console and shell, one more tab was introduced, something in which we could put our codes, return explanation, and something with the word starting with D.
You're saying this markdown, is it? Markdown.
Yes, sir. Yes, sir. Markdown. Sorry.
Yeah. So
if you have time, can you tell me how to add that one? And
the markdown, adding markdown here is quite simple. So you just need to click on the files and add a file and say, just say notes.md or
.md.
Yeah,
okay. Anything .md.
Yeah, anything .md. Yeah.
Okay. Fine. Thank you, sir.
Yeah. So all right, going back to this problem, anyone has any doubts regarding this?
Sir, not regarding this problem, but one of the week 3 problem, in which like we were required to produce like multiple number of stars in a pattern. So I had started doing that question via for loop, but
Okay.
in sample it
Yeah,
was provided.
Yeah. So sorry to stop you here, but tomorrow this will be discussed, right? So today's activity.
Okay.
All right. Yeah. So anything regarding this week's activity, we can maybe for 2 more minutes. If anyone has anything, we can. Yeah. So anyone has any doubts with this particular problem, or is it clear?
So that adding of those rows is a little bit confusing. I mean, the lines, I think 14 to 18, that's not very clear with that.
Yeah. So see, what is happening here is there are the original matrix is of size n by n, right? But we want to pad it with zeros on either side, top, bottom, left, right. So we end up adding one row at the bottom and top, one column left and right. So that's why we have n plus 2 cross n plus 2. Okay, so that is the reason for these two lines. Now, what we need to do is, if it is 0 to n, if it's n plus 2, essentially in terms of indices, it is 0 to n plus 1. And it is 0 to n plus 1. So what effectively we need to do is we need to embed the old matrix in this new matrix, right? So the old matrix will occupy the indices 1 to n, right? So 0 is to the left of 1, n plus 1 is to the right of n. So anything from 1 to n is nothing but the old matrix itself.
Yeah, got it, sir. Now, yeah. That was what was the confusion.
Okay. So that is, once that is clear, this should be straightforward, because you're just, again, you're checking from 1 to n plus 1, 1 to n plus 1. You don't need to check for anything outside of it. Okay, so we have done quite a few problems, but some important ones are left out. Maybe we'll cover this in Tuesday's session. So there is no session on Sunday. There is one tomorrow. So whatever we have left out is, I think, more important for the upcoming weeks because they are all to do with lists. So what we will do is, we'll see if Tuesday's session we can cover these remaining questions. Okay, so yeah, so that is all I have for today. Yeah, so I'm getting few more questions. How much time will be there in the test to solve program? Actually, to be honest, I also don't know what the quiz is going to be like for Python. So once I know that, I'll get back to you. How to run the code in main.py? Without main.py, can you check out this Replit session? We had one session for Replit. It was the very first session.
Yes, sir. I check out that, but I can't get it.
See, what you have to do essentially is you have to so import. You have to, if you are like say creating a new file and you're writing some code here, right? And like print, and you want to execute it in main.py, what you have to do is you have to simply type file1, the name of the file, and you have to run this.
Okay, so every time I have to write this.
Yeah, if you want to run it from outside main, yeah.
Okay, okay. Thank you, sir. Thank you so much.
Yeah.
Great session.
Yeah. So do we have to code during the quiz? You may have to. I'm not sure. We will get back to you on this. Okay. Thanks for staying, everyone. We are closing the session now.
Thank you, sir. Good night.
Good night all. So Akshay, we can close.
Okay, sir. Good night.
Good night, guys. Good night.